First of all, thank you to all of you for joining our Observing Earth from Space, an Introduction to Astronaut Photography of Earth webinar. My name is Paige Graff, and I'm the lead facilitator for today's event, but also on the line with me today are Suzanne Foxworth and Julie Pouchet, as well as our guest speakers, which we'll introduce in just a moment. But more importantly, we really want to welcome all of you participants. We have folks from all over the United States, 23 different states and Puerto Rico. We didn't get you on our map, but you're there. And we're so glad to have all of you who work with learners of various ages, whether they're students in grade school all the way up through adults. We are so excited to have all of you on the line with us. We certainly couldn't host our event today without our featured speakers. Britton and Andrea Meado are scientists from our ARES Earth Science and Remote Sensing Unit here at the NASA Johnson Space Center, and they're going to share with you the work that they do on a daily basis. Now, they are very busy individuals, so we're very lucky to have been able to take some of their time so they can share this amazing work that they're able to do as part of our Earth Science and Remote Sensing Unit. So they'll introduce themselves in just a moment. The other thing I'll just mention is that if you are interested in upcoming webinars that we might be hosting, you can always check our webinar website. We do host webinars almost on a monthly basis, and we will have one in May. Our topic is to be determined, but we really hope that you might consider joining us for that as well. So with that, again, I want to welcome all of you. I'm going to stop sharing my screen, and I'm going to turn things over to Andy. Thanks for joining us.
Yes, thank you, Paige. So today's webinar is on observing Earth from space, an introduction into astronaut photography of Earth. Andrea and I, we work in the Earth Science and Remote Sensing Unit at NASA JSC. Where part of our daily job is to work with crew Earth observation photos and deliver them so that they are publicly available. And if you can see the next slide, we're a creative team of Earth scientists, GIS analysts, and computational scientists, and we work with astronaut photos of the Earth. We support the NASA International Space Station Program Office, and we do payload operations for the Crew Earth Observation Facility, where our payload is handheld digital cameras that astronauts use to take pictures of the Earth. We curate and host astronaut photography, all that goes onto an online database, so that every picture that is taken of the Earth is available for download. We also have an immense interest in not only just the Earth, but the Moon as well as Mars as NASA explores further. And a little bit about myself. My name is Andy Britton. I have a geology/Earth and space exploration bachelor's degree from Arizona State University and a master's from University College London in the UK in space sciences. And my colleague Andrea, if you want to tell a little bit about yourself.
Hi y'all, so my name's Andrea Meado. I'm a geologist as well. I primarily focus on Earth, but like Andy said, our group is starting to venture more into remote sensing and GIS of the Moon and Mars. And I did my undergrad in geology from the University of Houston, and I have my master's in geology from Southern Illinois University.
So part of what we do with Earth astrophotography is we do support the ISS program. That's this image over here on the left. Here you can see the ISS from space, and the edge or limb of the Earth to the right as this photo has been rotated. We facilitate imagery requests from scientists of all types, including nighttime photography. As you can see, Here's a city with a river running through it. We also do disaster response, and that is an important aspect of what we do. Sometimes we will task astronauts to take pictures of wildfires, flooding, volcanic eruptions, and much more. We write weekly articles. We have a group of 5 writers that rotate once a week on our Earth Observatory.nasa.gov site with our Goddard colleagues. We have a astronaut photo that it typically shows up on Sundays, and every other day there's another photo from a different satellite or a different camera, a different instrument. So we do write articles, and then another thing we do in our group is we are doing machine learning. Our group has become advanced in machine learning, using algorithms and developing them for making things such as cloud masks. Here, this image in the center is a cloud mask where the bright pixels are where the cloud has been automatically identified, and the darker area is likely would be water or land. You can use these cloud masks for various types of classification of where there's land, and maybe just kind of analyze that part of the astronaut photo. And then all of this type of using algorithms helps classify and tag to make our photo database much easier to search. We have over 3.5 million photos. Our machine learning algorithm not only does cloud maps, but does auto-identification of the Earth's horizon, the moon, cities, aurora, and more to come. So a brief history of astronaut photography. This goes back all the way to Mercury and Gemini times, back in the 1960s, all the way through Apollo, Skylab, Mir, the shuttle, and even to today with the International Space Station. This is an immense data to sort through, organize, and make accessible to the public. Some challenges is that these photos are taken by humans at a variety of different angles and rotating the camera and so on. So it's a huge database to go through. As I said a little bit before, we have over 3.5 million photos that astronauts have taken of the Earth.
Yeah, I'll add in. So on this right photo from the ISS missions, we're looking at a picture of the Texas Gulf Coast, and so that city on the land is Houston. And even though we can tell where this picture was taken, the ISS might have been, well over Louisiana or over Florida by the time it was taken. And so it's kind of hard sometimes to sort through such an immense database of imagery, and so that's why we use machine learning and such on our website, which is the database we keep referring to, and we'll share that link with you all in a little bit.
So a question I'd like to pose all of you attendees into the chat is, what year did humans begin continuously living and working in space on the International Space Station? So if you could go ahead and answer in chat.
So if you're using the archive, this becomes a great way to kind of get a perspective of what are people thinking? What do our kids or learners or adults know? So we have a variety of answers, including Y2K or 1994 or the year 2000. We've got some 1999s and 95s. Someone mentions 20 years ago. A lot of 1999s out there. Now think about this is for the International Space Station. So we've got 1980s as a possibility, 1990s as a possibility, and it looks like the bulk of folks are thinking maybe 2000. So a wide variety. So Andy, clear this up for us.
Yeah, so the answer is astronauts have been continuously living on board since 2000. This is a shot of the International Space Station. The ISS orbits about 16 times every day, and that's about once every 90 minutes. It's at an altitude of about 250 miles above the surface, and this really gives us a lot of opportunities for astronauts to take pictures of the Earth. And I know one thing that astronauts really like to reflect on, and that's really cool, is that astronauts get to see about 16 sunrises and sunsets over a 24-hour period. So they get to have a unique kind of experience of time and as well as all the visuals, of course, as well. So here is a picture inside the space station. Over to the left, we have an astronaut holding a large camera with a long lens in the ISS cupola window, which is a module of 7 windows that's pointed downwards towards Earth. And over on the right, we have another window, which is called WARF, which stands for Window Observational Research Facility. This is an optically pristine window that astronauts like to take pictures out of. The quality of the material is very pristine, so that gives us really high quality images back here on Earth. And up at the top, you can see that there's a large assortment of different cameras and camera lenses to choose from and to swap in and out for what astronauts want to capture in the moment. And there are benefits to astronaut photography. One thing is that there's variable solar illumination angles, meaning that you can see the same location time of night or day. So here we have an example of Italy looking north up the peninsula. You can see the boot, and then there's a daytime image, a dusk or dawn image, and a nighttime image. So this helps us really be able to observe cities. And the ISS really complements Earth observing satellites because those are in an orbit, in a polar orbit, where they typically see the ground one time during the day, either in the late morning or in the early afternoon. So the ISS and astronaut photography can really help complement that by offering different times of viewing the Earth. So a photo of a dust storm, say, might be special towards the later afternoon because the late sunset or the late sun hours really have played a role into lifting some of that dust. And so that's how astronaut photography can really complement Earth satellite data as well. Another thing is that astronaut photography offers variable look angles. You can see the peninsula of Italy here in different angles. Down into the lower right, you can see there's a little bit of sun glinting off the Adriatic Sea. So using different look angles, we can have a different perspective, get a different sets of depth of a photo. And with the sun glint, we can also see things like what the water current or swell action is doing, is the wind drive, how much the wind is driving the waves and their interaction of the water surface at that point of day. And so for next, what I'm going to show you is the variable camera lenses and how those affect our field of view and the magnification. So here, again, we have the peninsula of Italy, and we have the Adriatic Sea. So with a wide field of view, we get a really regional perspective. And I'm going to zoom in. Let's zoom into Venice. So my next photo, that is where that red box is. And so you can start to see some clouds. There's agriculture in the region, and with an even longer lens and a greater magnification or greater focal length, we can see even more detail. Now we can see Venice just poking out, and you have the lagoon and the long beaches. You can see some sediment suspended in the water. And zooming in further, you can start to see some of the straits, the maybe a major canal, the bridge that goes from Padova to Venice. And then zooming in all the way to about an 800 millimeter lens or greater, you can start to really see the different canals of Venice, the red roof, and so on.
This is another example of why we have such a vast data set of astronaut photography of Earth that we work with, because it really can be anything from a wide view looking at Earth's horizon to being able to see canals and streets of cities.
Yeah, thank you. So different fields of view come with different camera lenses. A shorter camera lens will take broad and wide pictures, such as this 16 millimeter example on the left. You can get a picture of the Earth's limb in almost like a semi-fisheye type of view. Here we're looking south along the coastline of California. You can see the Sierra Nevadas and the Central Valley. There's the San Francisco Peninsula and Bay Area. And if astronauts use more of the 50 millimeter lens, you get a photo like this where we still have California. You can see the Central Valley. We're looking south, so Los Angeles is just to the upper right. And the 50 millimeter lens is about what type of field of view you'd kind of see with the human eye looking out the window of the ISS. And with a much longer lens, a greater focal length and more magnification, we have an example here of San Diego at 400 millimeters. And again, part of our group does crew Earth observations, where we task astronauts on the ISS to photograph Earth from their unique point of view. We provide daily targets on Earth for astronauts to take photos, and these targets are evaluated based on where the ISS is orbiting over at a given time, the lighting conditions. We have requests that come where they're specified for different types of day or even at night. And then we also need to take into account the weather and the cloudiness. Some targets do ask for pictures of clouds, but maybe most do not. And over here on the right, we have NASA astronaut Christina Cook looking out that seven window cupola module.
Yeah, I always like pictures like this one of the astronauts in the cupola window, because it kind of gives you an idea of how big or maybe small that module is, and then all of the equipment kind of packed in around it. And usually astronauts have told us when they're taking our crew Earth observation targets, they usually have 1 or 2 laptops set up with the maps we provide, and just other equipment around. You can see a really long camera lens kind of just tucked away. Looks like it's maybe ready to go for a later shot. Looks like she's got some sort of variable, kind of adjustable lens in her hand. And I don't know where they're at right now, but it just looks like clouds and ocean underneath the space station.
So as part of our CEO payload, which is, again, the handheld digital SLR cameras, what they do is active science imaging as well as disaster response. So for the next part of the slide, images help support science, whether we're looking at change over time, change of the climate. Other change can include urban growth, light pollution. We do have a lot of nighttime images, and our nighttime images are some of the highest resolution, freely available data products that you can find. And for disaster response, astronauts are tasked with imaging wildfires, hurricane damage. Here in this photo in the center of the eye of a hurricane, this really helps scientists understand the structure of the eye. Images of floods can really help for assessment and so much more. These are requested through our website where we ask the astronauts to process to take the images. They get sent down to the ground where we process them, send them out, and they're all publicly available. We work with the International Disasters Charter and NASA Disasters Program to have astronauts take images of disasters as they're happening. Other types of disaster response would include smoke plumes from these wildfires and volcanic eruptions. So to make this webinar a little bit more interactive, how might you use this astronaut image? What type of image do you think this helps support? Science, disaster response, and what type of information can you obtain from this image or an image like this? If you want to put in your answer in chat.
So this is a great way to be able to have learners think about, or even you think about how you can use this photo. So science, disaster response, and what can you obtain from this visible wavelength image? And so I do see someone has mentioned disaster response. Someone has also put in there disaster response, as well as you can look at the direction or fallout or drift. Now, some of you may not even know, well, I don't even know what we're looking at. I'll give you a hint. These happen to be smoke plumes, as someone has put in, our solar system ambassador from California. So it looks like someone else is saying you can do some science as well as change over time. Someone else is mentioning disaster response and where the hot spots are. Wind direction is another thought based on the visual image that you're looking at. Someone else from Chandran Public Library mentions disaster response and science. Maybe you could look at the same area over time to see how far fire modifies the landscape. Someone else has indicated that you can do disaster response again and look at the geography, as well as someone else has included you can look at fires and perhaps what we are looking at here. So Andy, what exactly was this image taken for? Can you share that with us?
Yeah, so this image is of California. We are looking west, and this is from the 2018 fire season. This blue lake in the center, this is Lake Tahoe. So it was used for disaster response. I forget the specific name of some of these fires. Here you can see that the winds are coming from the west, and blowing the smoke east. So that can definitely play a role in purity, whether breathing these smoke is harmful, and how far the smoke plumes are traveling from these wildfires. And if we go to the next slide, you can see a different view. We collect and deliver this data, and we georeference it. So first, we take raw image camera files, and we create ground control points where we take a pixel and a number of pixels on the image, and we tie them down to a map, therefore creating a georeferenced product like this on the right. Here we have the smoke, where the smoke plumes and Lake Tahoe orientated correctly on a map, where north is up and east and west and south are all in your typical cardinal directions. And then we take this data set and we deliver it to the United States Geological Survey so that it can be delivered to NGOs and the people and scientists that are interested in this disaster and how to respond to it. This view is a slightly different view from the previous image. We are currently looking east, and north would be to the left. So let's go to another one. How might you use this image? What do you think this type of image would support? Science, disaster, and what kind of information do you think you could obtain from this type of astronaut photo?
So again, as we look at some of the answers coming into the chat window, the first thing you're hopefully orienting yourself to is, what are you looking at? And then immediately some of you have jumped in and said you can study things related to science like climate change or potential water volume during melting. It looks like snow, someone has mentioned, so you might look at change over time as part of some type of science research. We've got a couple of other science answers in terms of this would be used or could be used for science and change over time. Glacial retreat, someone mentioned. Loss of ice, whether this is Arctic ice or some other location. Global change over time. Historic data for movement or change of ice over time. So this could actually be used off as a jumping point for an art project. Absolutely, and some of you might look at some of the textures in this image and it can become a writing prompt, it could become an art project, or it could be used for disaster response and potentially flood assessment, climate change, snow melt accumulation. So we've got some really good answers in there, and I love that art project. Thank you, Barton County Library. Great answer. What do you think, Andy?
I think all those answers sound great. So this is a photo particularly concentrated on how glaciers change over time. We are looking at the South Patagonia ice fields. And if this main glacier right here, if I kind of highlight that, that is the Viedma Glacier. And I think Andrea has had students tell her that this often looks like a frozen slide. If we zoom into this image, here you can see different astronaut photographs of the same glacier throughout the recent years, with the upper left image taken in 2007, and then our upper right image taken in 2016, and our lower left image in 2018. We have the end of the glacier, the tongue, retreating around this point here, where it used to curve around and kind of empty out into this lake. And these are measurable. And we can georeference these images and tie these down to a map and really visualize how these glaciers are evolving over time, how the climate in this area is changing over time. And besides looking at the end of the tongue of the glacier, you can also visualize how the moraines are changing over time. Moraines are these stripy linear features that are running parallel to the glacier. So those also change over time, and you can really investigate those with astronaut photography as well.
So I'll add in as well, one of the great benefits we have of having, decades of manned space flight is we do have great pictures of change over time, and these glaciers are an excellent example of that. It's one of our long-standing research requests that we pretty much ask for new pictures of these glaciers every year, twice a year or so, so that we can keep that database going.
So for our next photo, here we have a nighttime image. What do you think this image would help support? Science or disaster response? And what type of information do you think you could obtain from this image?
So as we do get some immediate answers in the chat, some are saying 1C, dealing with light pollution. We had one come up right away and say urban sprawl, population density. Maybe you can look at change over time, or even light pollution and how that changes over time. It could be interesting for dark sky astronomy. Would this be a good place to look at the stars? Urban growth again, urban sprawl. Let's see, electrical grid locations and monitoring. So at least you might get a sense that there's certainly quite a bit of electrical grids going on in this particular area. Population density, again, I like how this answer is put out there. 1, science, B, urban growth, C, light pollution, and D, you could look at perhaps some information from the Department of Energy and energy use. And someone else has mentioned from Keyshore County Library, river change course. You can certainly see the meandering of this river in this image that's almost sort of, well, the opposite of lit up from these city lights. So that is a really interesting approach and view and take on this image. Someone else has put in there different types of lighting, perhaps noticing that there are sort of yellowish and whitish colored lights. Someone else has put in different approaches to city and urban planning. So we've got some amazing responses, actually, things that I have not even thought of myself, and even flood planning, someone has mentioned within a couple of those responses. Very interesting responses on this one. What do you say, Andy?
Yeah, great responses. Every pixel inside this image can be thought of as a piece of data. So these images are really powerful, and images really are data. So what we're looking at here is a nighttime image of London, and you could use this for so many things. Just a couple include light pollution, urban growth, and so much more. Here, this dark feature running left and right in this image, east and west, is the River Thames of London. We have some dark parks over to the left as well, including Hyde Park and Regent's Park. You could do so much with this type of image. The color of lights can definitely play a role of the history of a city, of how that city developed, other different factors of a city as far as being industrial or an old part of a city, residential, and so on. There are so many things you can do with an image like this. For disaster response, you could use nighttime images for such a thing, especially if a disaster causes blackout of an area. So we've had kind of requests for those.
I saw a question in the chat about comparing resolution of satellite data to astronaut photography, and really it's quite variable. It just depends on the camera lens that the astronaut uses. It also depends on the resolution of the satellite image. So like Andy had said before, for this particular example, a really good advantage to astronaut photography of cities at night is that this is the freest or highest resolution freely available night imagery to the public, and compared to some other night satellites that are also freely available, this is much clearer pictures and resolution.
Yeah, so these are really powerful. So now that you've learned the astronaut photography basics, let's explore some additional images, including this background image that has been used for a number of slides. What features do you see in this astronaut photo?
If we have any astronomers on the line, we might get some interesting answers. So right away we get an M31 Andromeda galaxy. We can see the atmosphere, air glow, day-night horizon folks have put in. You can detect the atmosphere. I always find it interesting, when folks do point out actual galaxies, because not being an astronomer perhaps ourselves, that might be a little harder for us to really confirm. We also have others that are saying streaks of city lights, even blurring of Earth lights due to motion and time exposure. Someone else is confirming that they do believe that you can see the Andromeda galaxy perhaps within that image. Anything else that's sort of up close right there from which you might see where these images are being taken from? So yes, here we go, parts of the ISS and the space station itself. It's almost so close to the view, it's almost easy to miss. So you can, again, thinking about that art project ability, this could again be a nice little way to incorporate art into some of your programs. But Andy, what else can we see in this photo?
Well, I think we had some really great answers and some advanced answers there. Yeah, so some of the items that we've labeled include stars, air glow, ionization of the atmosphere from space, the ISS spacecraft, of course, and lights on Earth. Excellent points made talking about motion blur and exposure, especially since the ISS is orbiting quickly around our great planet. So for another example, where in the world do you think this is taken, and what do you think the different colors of blue represent? And I'll give some hints. This is near North America. It is not too far away from Florida, so I'm seeing some good guesses of the Bahamas. And for different colors of blue, yeah, the depths of the water would be the correct answer, where darker blues represent deeper waters, and more shallow cyan, seafoam green, and lighter colors of water represent shallow depths. So here is a couple of islands labeled. We're looking at the Bahamas, including Andros Island and the Grand Bahama Islands. And there's a lot of popcorn types of clouds near the islands, so those are always interesting to look at, and people study those using astronaut photography. Andrea, do you have anything else to say? There is a number of ISS hardware in the shot as well.
Nothing else to add about this particular one. I think really what strikes me the most is the different colors of blue, indicating really kind of quick changes in depth, where the shallower water is the light blue. And then it can quickly drop to much deeper water, which is where you see the dark blue colors.
Yeah, excellent point. So for another example, what features can you identify in this image?
And so as you're looking at this one, you might, again, as you're getting oriented to the wide variety of features that you can see in these images, some of you straight off the bat are saying that you can see mountains. Some of you are actually mentioning that there might be some evidence of some drought conditions. I'd like to hear why you think that, Glendale Public Library. Others are saying looks like a rain shadow, mountains, snow, glaciers, rivers, lakes. The antenna are part of the International Space Station. You can see snow-covered mountains. Perhaps this is the Sierra Mountains, not quite sure exactly where we are yet. Lakes and clouds and snow. And, you know, I really think that interesting comment from one of our participants about drought conditions is quite interesting, because we do have a little bit of a two sides of the story here. Is that right, Andy? What are we looking at here?
Yeah, that is true. There is quite the dichotomy here. We are looking across different climate zones of the Earth over India and China, and we have Mount Everest in the image as well. So yeah, there's a lot of great answers here about lakes, mountains. You can see the limb or edge of the Earth, and we're looking west from the ISS. There's maybe some atmospheric phenomenon with India due to either economic activity or burning of some type of biomass. There is somewhat of a rain shadow caused by the Himalayas. The warmer kind of tropical types of air can't really push north towards China because of the mountain range. And yeah, there is the kind of ISS hardware at the top of the image as well. Andrea, do you have anything to add?
So these types of photos, really looking broadly at Earth's horizon, I think these are pretty powerful to give you a sense of literally different climate zones being separated by, you know, one of the tallest mountain chains in the world. You've got the Tibetan Plateau of China on the right side. It's known for having thousands of these lake beds. India to the south, and then just lots of cloud coverage and snow within the Himalayas. And I saw a question asking why isn't scale included on these photos, and we don't ever include scale on astronaut photos because they're almost never taken perfectly nadir, looking at the ground. So the scale kind of in the foreground is different than, the scale or size of the image is further away in the photo. It just depends on how kind of warped or oblique the image is. And so we typically don't include that.
Right. If you could place the scale bar and if you placed it, say, at the bottom of the photo, it would be of one length. But if you pushed it out towards the top of the photo, if that scale bar could change dynamically, it would shrink because we're looking over a vast distance, and that scale bar wouldn't be true for every part of this photo. So that's a great point.
And so this type of picture, so kind of with your human eye focal length from the altitude or the altitude that the space station orbits at, about 250 miles above Earth's surface. With an astronaut's naked eye, they can typically see about 1,000 kilometers away towards that's as far as the horizon they can see from the altitude they're at.
Yeah, and over on the left side of the photo, over India, there are a lot of meandering rivers kind of streaming from the glacial Himalayas as well. So yeah, lots of great answers. Thank you. So this is another popular type of photo. I think when Andrea presents these to some kids, their eyes really light up because of the bright, beautiful, brilliant green of the aurora. This is the aurora australis. And can anyone guess where we might be orbiting nearby?
So perhaps he gave you...
I said australis. I meant borealis.
I was going to say, one of those words should give you an idea of which part of the world it might be in. And maybe in the interest of time, now that we went from the south to the north, so which are these and where are we?
So we're actually orbiting over northwest Canada, just over the Pacific Ocean, and we're looking north towards the Yukon Territory and British Columbia. So we're not too far from Seattle, Washington, probably, and the Canadian Rockies. And so a lot of people are interested in these types of photos for studying the morphology of aurora and the various features that come with aurora. So I think we'll press on because of time, and Andrea will talk a bit about the freely available resources that we have.
So we keep talking about our database, and what we're referring to is our website, the Gateway to Astronaut Photography of Earth, and this is where we host the over 3.5 million images that astronauts have taken of Earth throughout the whole span of manned spaceflight. And there are different ways to find images on our website. You can search for photos by map area. You can search for photos by geographic features or by dates that you might be interested in. Something that might be a little more digestible, or if you don't know what you're looking for, you just want to browse, you can go through our collections pages and look at series of volcano photos, glaciers, cities, such like that. We also have lots of time-lapse videos, and you can also request science imagery through our website as well. So next slide, please. So every photo we have has its own metadata associated with it. Every photo's got its own web page, and so here's an example of a photo of Puerto Rico. And what we do is every single photo has metadata downloaded with it from the camera file when the picture was taken, and so we know the exact time the photo was taken, and then we can run some scripts that we've written in-house to essentially know exactly where the ISS was at that time the photo was taken, and so that's the spacecraft nadir point. And then quite a few of the photos on our website have also been manually cataloged, so that means we assigned a lat-long center point and some features, like whatever is in the photo, some sort of geography. But that's also why we use machine learning, because we can't keep up with all of the photos that we get in from space station, and so we use machine learning to automatically identify some of these features. Andy briefly mentioned this earlier, but we do write weekly articles for NASA's Earth Observatory. This is the flagship Earth science kind of news website for NASA. And so, yeah, typically on Sundays we have an article on a recently taken astronaut photo, and these are meant to be very easy to read at kind of the junior high, middle school reading level, and it's one of my favorite parts of the job is getting to write for Earth Observatory. So we have a couple of ways that the public can interact with our data in a way that is useful to us, and one of them is through an in-house activity we call Feature Hunter. And so this is an activity where anyone can kind of go through the tutorial and draw boxes around certain features that we are interested in, like volcanoes, cities, rivers, glaciers. And then that box becomes data that we can use to train our machine learning models. Because in order to be able to build a machine learning model that can automatically identify a volcano in a photo, it needs to know what a volcano looks like, and that can take a lot of time to sort that sort of imagery out. So this is like us using the public to help us create that data set so that we can make our website more searchable. And another one we have is called Image Detective, and it's similar, where we have just people from the public assign lat-long center points to astronaut photos, and then some key features in each photo. So, for example, this one's of Houston and Galveston, and it was cataloged by the public, and that makes this sort of photo more searchable and easy to access through our website. And so, before we take questions, we're going to go through this compilation of night imagery, or yeah, if you want to mute the video, Andy, we don't need the music on it, but as it plays, anyway, so this is a compilation of different night time lapses that astronauts have taken from the International Space Station. And so what that means is the astronaut will set up a camera, usually attached to like an arm or something, in one of the windows on Space Station, and set it up to take a series of photos every second, a few times a second, for however long they desire. And then we take those hundreds or thousands of frames and compile them into a video. And this particular one, we're looking at Aurora over North America. I'm just going to kind of narrate through them as the videos play. Here we're passing over Italy at night, and then going over other parts of Europe, and then you can see, looking into that distance on the horizon, that 1,000 kilometers away, you can see the northern lights moving along. This particular video is interesting because we're looking at the cupola, and you can see the shields pop open, and an astronaut actually taking photos out of the cupola, which means another astronaut had to set up the camera from another window to take this time lapse. And then if you see that circle going up across the screen, that's actually the moon rising through the shot. Another spectacular video of Aurora. Here we're going over the Canadian Rockies again, Alberta and such. And it's pretty much like the ISS is almost going through the Aurora. It's slightly above it, but it didn't get quite close. And this interesting shot's using a fisheye lens. I'm not sure where it's over, but sometimes astronauts choose to set up more of an artistic kind of video. And this shot's going over the Nile River Delta, Mediterranean Sea. You can see the island of Cyprus lit up. And then we're going over the Middle East area. Yeah, I agree. These videos with the aurora are very soothing. This one's, we just passed over the Great Lakes, and now we're ending on the east coast of the U.S. And then this video seems to be focusing on the stars, and then on the left side you can see a comet actually traveling through the shot. I think that's probably one of our more unique videos overall. And then you can end it there. So with that, I will be happy to answer questions that y'all have put in the chat. I think I'll rely on Paige to pick out her favorite ones, and we'll be happy to stick around and answer some questions for y'all.
And if you rely on me to pick out my favorite ones, they're all my favorites. And so I'm going to do my best to be able to get through as many questions as possible. But first, I will make note of the time. It is the top of the hour. If you are able to stick around and you want some questions answered, we will stick around for 15 to potentially even longer to be able to answer as many questions as possible. But if you do have to depart, before you do, thank you to all of you who have joined us today, and a special thanks to Andrea and Andy for sharing these amazing images that when you think about utilizing them with your learners, think about art, think about writing, think about music. There's so many different ways that you can have fun and inspire some of the folks that you might work with using these photographs from the International Space Station. So if you've got to go, we understand, but let's get to some questions. So first of all, there were some questions that came in early on, and they had to do with the training of the crew. And so a question for Andrea and Andy is, can you talk a little bit about how much training do the astronauts get with the cameras or the equipment or about imaging the Earth from space before they actually fly in space?
Yeah, I'll answer that one. So specifically to our payload, the astronauts get anywhere between 1 and 5 one-hour classes, kind of in-person one-on-one, and we talk about the different kind of science requests that we have at the moment and what that we might be focusing on during their missions. We also do kind of general Earth science topics and such. Astronauts go through some geologic field training as well when they are still astronaut candidates that part of our group helps work with. And then the astronauts are also trained on how to use the cameras. And that is run by a different group, but we work fairly closely with that group. And I'm not exactly sure how many trainings they get, but I know they can check out cameras and like practice with them for as long as they need to or want to before their missions.
And so one thing to understand about the astronauts and the training that they get, they have so much on their plate. And the imagery is one portion of so many other portions that they go through with their training. And so sometimes they ask for additional training with different aspects, including the astronaut photography. We have been lucky that we've had some great photographers go out to provide us with what you saw here, some of these amazing images. Now, related to sort of the imaging Earth from space, do they ever use these handheld cameras for photographing and doing any kind of exterior inspections of the ISS, or do they mainly focus on Earth from space?
So our payload mainly focuses on Earth from space. There is another group at Johnson Space Center that uses various images from EVAs, approaches, and disembarkments from spacecraft to look at the structure and the materials of the International Space Station, but that's a separate group. Andrea, do you want to talk anything more about that?
Yeah, that group is the Image Science and Analysis group. It's kind of like our sister group. We all have the same. We all work under the same organization, and they'll use some astronaut photos of the exterior for, surveying equipment. They'll also there's all sorts of external cameras on the space station as well that can be controlled by people on the ground, and so that might not be controlled by an astronaut, but there are all sorts of cameras outside of the station taking photos that can be moved around robotically as well, so that they can assess for damage and such.
And I've heard from this group that some areas of the International Space Station haven't been seen in a while. The space shuttle did offer some different views of the ISS that were kind of unique to the space shuttle because of the different types of maneuvers it could do, and the kind of altitude it would go to during approach and inspection.
Yeah, that's a really good point. When the astronauts were flying in shuttle days, actually astronauts on the space station would take pictures of the undersides of the tiles of different shuttles, and then the image science and analysis group would inspect that imagery for damage. So, we do use astronaut photos for a variety of reasons.
Awesome. So, related to imagery, and this is all about, imaging, and think about the folks that you might work with and the photographs they might be taking themselves. We've been looking up at the sky and use astronauts looking down at the Earth. And one of the questions that came in was related to how difficult is it to get steady images with the ISS moving so quickly, and astronauts especially, is it especially hard to get a clear, not blurry image when they're using long lenses? Any thoughts on that?
Yeah, so kind of talking to my predecessors and astronauts in general, back when the digital cameras, like, a decade or so or more ago, weren't as good. Sometimes the astronaut would actually have to move the camera with the shot to compensate the motion of the ISS. Nowadays, the cameras are pretty good. I don't know if they have to do that motion compensation quite as much anymore.
And those long lens shots, since you're so zoomed in on a particular feature, can be very challenging. Let's say an astronaut is trying to get an image of, let's say, meteor crater in Arizona. They have to be at that window at the right time, being able to know exactly where they need to focus, and then be able to get a good shot and not miss it before they've passed the feature of interest. So like Andrea mentioned earlier, since so many of these photographs are not taken at a nadir or straight down view, that's what makes it too difficult to put a scale on an image. But you can certainly get, as Andy mentioned, the variety of angles in which you can view a particular area, which really can complement some other remote sensing data that you might be looking at. Now, one of the other questions that I did see come in was, can you use astronaut topography to obtain relief or height information, elevation data, from the ground, or would you need a complementary data set in order to do that?
I would say that you can. You can use the angle of the sun and the lengths of shadows to get an idea of how tall some mountains are, or how deep some kind of negative relief features are, such as canyons or impact craters that we have on Earth. So you can use the same kind of taking the tangent of the length of the shadow method that we use for looking at a simple view of depths of craters on the moon or Mars. And it would always be good to have a complementary data set to our astronaut photography for that type of purpose. What do you think, Andrea?
I think you answered it better than I could. Yeah, you could make measurements from these types of photos, but it definitely would always be advantageous to have a known, like, scale of or size of something within that photo, like a reference.
And the other thing that I'll just add is you would need to have all of that data as part of the, as Andrea said earlier, metadata. So without the solar illumination angle and without knowing the angle in which that is coming from, you do need a lot of that information to be able to obtain that data. So that would be pretty advanced. But here is a question that someone had come in about recommendations, and this actually was a pre-question that came in. What kind of recommendations would you have for someone who enjoys photography and might aspire to have a position with NASA or Earth or Mars or any kind of space exploration? Any thoughts on that?
Well, there's a variety of people that work for NASA or in general as either civil servants or contractors. There's everything from social media outreach to scientists to engineers to just kind of a whole variety of professions. And maybe I'm rambling. I don't quite know where to go with this question, but
Yeah.
there's something available for most interests. You just got to look for it.
Yeah, if you are interested in photography, you could take that to the route, some of which Andrea mentioned. You could take that to working in educational public outreach with a great person such as Paige and her colleagues. You could take that to learning more about the algorithms that are associated with machine learning and develop computational skills, learning how to write in languages such as Python and others, or you could take that and try to learn more about geographical information systems and software to how to take astronaut photography as well as other satellite visible imagery and apply that to making maps and various other types of data sets.
Yeah, another thing that the Image Science and Analysis group does is they'll use photogrammetry from different photos to make 3D models or renderings of certain, spacecraft parts or whatnot. And so, there's a variety of things you can do if you've got a good photography and technical background.
As well as we have a group here at Johnson Space Center that works with VR, virtual reality headsets, and gaming engine software to basically visualize the terrain of the moon or Mars and future landing sites for both human and robotic exploration. So you could also take photography into that type of direction as well.
And the one thing that I'll also add to, these different science pathways, and it's all about these different pathways and the exposure we can provide our learners with what direction they can take their interests. And Andy and Andrea have covered so many different variety of career pathways that a student or a learner could take, especially in the science realm. But don't let them forget about that art area. NASA does have artists as well that draw artist renditions of potential future missions, or even just, we have artists that work with imaging of rocks and being able to scan some of our lunar samples, which we also happen to work with here at the Johnson Space Center. So photography of other worlds, as well as in the GIS and science world, but also from an artistic and a science blend is also a possibility. So there's so many possibilities out there for kids of all ages, including some of you adults that might be looking for ways that you can help with some of this imagery. And I think in looking at one of our questions, someone asked, how can we best assist this group with some of the projects you're working with? And Andrea mentioned the image detective as well as feature hunter. And kids of all ages, especially for feature hunter, could help our machine learning algorithms, and that is such a great help to our team, as well as Image Detective, which is a bit more complicated. If you like a challenge, finding that center point, latitude and longitude, it is challenging, but those are ways that you all, whether you're an adult or you work with adults or younger learners, those are ways that you can actually contribute to the work that Andrea and Andy do on a daily basis. So we'll send information out on Feature Hunter and Image Detective as well, so you can take a closer look at those. Now, I think one of my last questions that I'm finding in the chat, and again, I want to be sensitive on time, so we'll take maybe one or two more, but here is one that came in, and it's from one of our solar system ambassadors wondering, how often do the astronauts download these photos to send down to Earth?
Yeah, so I would say astronauts, downlink their photos daily. I would say almost every single day we're getting new imagery downlinked, processed, and added to our website. So it's kind of a continuous flow, just about, depending on how much photography is being taken as well.
And do those images come directly to the Johnson Space Center in Houston, Texas? Is that the who gets those images to then start working with them?
There's a whole process to downlinking data that I'm from space station back to Earth that I'm not completely versed on, but I know it gets sent down to some receivers at a different location. That data gets transferred over to Johnson Space Center, and then from there, there's a certain group that is very diligently works on all imagery that comes in, and basically all files that come in from space station, and then they kind of spread those to who needs to get them. That work there.
Awesome. And our group actually curates and takes care of all the images that do come in. So Andrea and Andy are part of a team that does work with this over 3.5 million images that are all housed in our Gateway to Astronaut Photography database. And so that's a lot of images, and they all have to, in a sense, be cataloged by hand, because a person with a handheld camera looking out a window at various angles took those images. So as both Andy and Andrea alluded to earlier, it can be sometimes challenging to know where in the world exactly is this image, and that's where things like Image Detective really comes in and helps. So here was another question that was about still photos versus video. Do the astronauts also take video, or are some of these videos created by your team?
Yeah, I think if you look at any kind of outreach or public, or what am I trying to say, videos posted by maybe like NASA social media and such, they definitely can take videos within station or of the Earth, but our group does not work with the video frame specifically. We only work with the photography.
However, can you make a video like that one that you showed using the still imagery, and how do you do that?
Yes, so they can set up a time-lapse photo, or set up their camera to take time-lapse photography, and then we'll get the imagery because it is a series of still photo frames, and we can stitch them together using some video editing software.
And those time-lapse videos, like the one that Andrea and Andy were sharing there at the end, even students can work on putting together time-lapse videos themselves by just downloading the sequence of images that were all shot a second or so at a time, one right after another. And that becomes a neat little video project that a student could work on if someone is into that type of thing.
I saw a question earlier asking about whether or not astronauts take like personal photos of the Earth, or if they bring their own cameras. And the answer to that is that there are cameras supplied on board, and so they'll use those cameras. And if they're taking their own personal pictures of Earth, that is still considered public domain data, and so that's all available on our website as well. Part of what we do besides the imagery and disaster requests is that we will also help the crew with their own photography requests that they might want to get pictures of while they have the chance to from the space station.
Awesome. And boy, space on the International Space Station is at a premium, so it can be challenging to want to bring up everything that you'd like to take with you. So using the assets that they do have on board kind of helps in a number of ways, especially with the fact that there's not a whole lot of room for people to be able to have a whole lot of stuff on board there at the ISS. Well, with that, I think I may have missed a question or so. I've been scrolling through the chat to try to find different questions, and I think for the most part, I think we've got to all of them. So with that, and it is about 22 minutes past the top of the hour, we certainly hope for those of you that joined us today and that remained on the line, we hope that we got your creative juices going in a sense, so that you can think about how you might be able to use some of this data, how you might be able to get the folks that you work with to interact and participate in some of the activities that Andrea and Andy mentioned, and if nothing else, how they can be inspired by looking at our Earth from space. What Andrea and Andy get to do on a daily basis, working with the astronauts, asking them to take imagery from Earth on a daily basis so that researchers and folks like you can enjoy the view from above. This is fantastic work that they do, and we hope that you and the audiences you work with might be able to enjoy these as well. So with that, Andrea and Andy, any closing remarks before we bring this to a close?
Yeah, thanks y'all. Thanks for listening, y'all. I hope you learned something and that you are able to utilize astrophotography for any of your learners, or maybe even just putting it on your desktop background. There's a whole bunch of ways to use it. So thanks again.
Yeah, thank you so much.
So thank you again for joining us. Thank you, Andy and Andrea. Thank you, Julie and Suzanne. And thanks to all of you for joining us today. Have a great day, stay safe, and we look forward to connecting with you again in the near future.